Welcome back to Backer Breaks It Down. Today we're going to take a look at bisecting a line segment. A segment bisector is a line, segment, ray, or point that divides a segment into two congruent segments. The point where the bisector intersects the segment is your midpoint. So if you are told that a point is the midpoint of a segment, then you can conclude that the segment has been divided into two congruent segments. So in this diagram here, I can say that segment AM is congruent to segment BM. I can make a similar conclusion whenever I'm told that something is a bisector of a segment. I can draw the conclusion that the segment has been divided into two congruent segments. So in this diagram here, segment AB has been divided into two congruent segments. Once again, AM and MB. Could a line or ray have a midpoint? The answer is no, because lines extend forever in both directions and rays go on forever in one direction. So they don't have an actual middle. So here are some really simple examples of midpoints. In number 1, you're given that E is the midpoint. So DE would be 9, because if the whole segment is 18, that means each congruent segment would have to be 9. And in number 2, N is the midpoint. So that means MN and NP are congruent. So NP is 11, and that would make the whole big segment 22. So let's take this problem up a notch. Here, EH is divided by F and G in the ratio 5:3:2. EH is 30 units long. So let's talk about ratio. They're not saying that EF is 5 and that FG is 3 and that GH is 2, because that wouldn't make sense. 5 plus 3 plus 2 isn't 30. It's a ratio. Remember, ratios are usually written in simplest form. So we have to think of this as 5 times a factor, 3 times a factor, 2 times a factor. And that these three things, these three smaller segments, add up to be the whole big segment. So 5x plus 3x plus 2x is 10x is 30. So that factor, that multiplier, is 3. So that means that EF would be 5 times that, so 15 units long, and FG be 3 times that, so 9, and GH would be 6. They wanted us to find FG, and I did that, and then some. FG is 9. The midpoint of EH, well, the midpoint divides a segment into two congruent segments. So F would be the midpoint of EH, because then EF is 15, but FH is also 15. Let's take a look at one more problem. Points OM and P are collinear, which means they are together on the same line segment, and that's what we see. OM is equal to x plus 8. MP is equal to 2x minus 6. And OP is 44. Is M the midpoint of OP? Okay, I cannot start this problem with the assumption that it is, because I'm not allowed to assume a point's a midpoint, even if it looks like one. There are very few things in geometry I'm allowed to assume, and midpoint is not one of them. But there is something that I know for sure, and that's where I'm going to start. I know the segment addition postulate says if I add the two smaller segments together, I get the whole big segment. So if I take OM plus MP, I get the whole big segment OP. This I know absolutely. So this is where I'm going to start. And from here, I'll determine whether or not M is the midpoint. So let's do some algebra. Okay. So I know that x is equal to 14. I'm trying to determine and prove, because all of this is part of my explanation, whether or not M is the midpoint of OP. So I'm going to find some actual measurements here of these segments. Well, OM is x plus 8. So that means OM would be 14 plus 8, which is 22. And MP is 2x minus 6. So 2 times 14 minus 6 is 22. Well, look at that. OM and MP are congruent. So I can say that M is the midpoint because it divides our segment into two congruent segments. And my work proved that. I proved that these two segments were congruent, starting with a fact. The fact that this segment addition postulate that says if I add the two smaller segments together, I get the whole big segment. So I didn't start with an assumption that M is the midpoint. I started with a fact, and I used that to prove that M is the midpoint.